Sections 8.5 and 8.6. Our objective today is I can define the sine, cosine, and tangent ratios for the acute angles of a right triangle. So first of all, let's review when we have a right triangle. So this is going to be my right angle. This is angle A, angle B, and angle C. And in terms of angle A is an acute angle of the right triangle. And in terms of angle A, we refer to segment CB, which is this segment here, as the side opposite the angle. Okay, and we refer to side AC, or leg AC, as the adjacent side of angle A. And of course, AB is what we call the hypotenuse. Okay, now it matters what angle we're talking about, because if we're talking about angle B, so this is angle A, this is angle C, and angle B, then AC would be considered the side opposite. So in terms of angle B, then this is the opposite side in terms of angle B. And I'm sorry, this is the adjacent side in terms of angle A. Okay? Then in terms of angle B, we would say that BC is the adjacent in terms of angle B. So this is the adjacent. Okay, and of course the hypotenuse is still the hypotenuse. Okay, now the sine, cosine, and tangent are exactly what the objectives say. They are ratios, but they're ratios that are related to the triangle, or the angle that we are looking at. Okay, so let's divide this up. Oops. Okay, and so this one is for angle in terms of angle A, and this side is in terms of angle B. Okay, so the sine of angle A, which we abbreviate SIN of angle A. And when we talk about angle A, we're talking about the measure, whatever this measure is equal to the ratio of the opposite over the hypotenuse. Okay? So in other words, the length of BC over the length of AB. Okay? The cosine of angle B, or angle A, I'm sorry, which we abbreviate cosine of A, is the adjacent over the hypotenuse. So this is the ratio, the adjacent over the hypotenuse. Okay? And then, of course, we have the tangent of angle A. And remember, when we say angle A, we're referring to the measure of that angle. So tangent of A is the opposite over the adjacent. Okay, I'm going to move this line because I need a little bit more room. Okay, so in terms of sine of A, it's the length of BC over the length of AB. And the cosine is the length of AC over the length of AB. And the tangent is BC over AC, whatever those lengths are. Okay, so that ratio is exactly equal to the sine of the angle. Okay, now going to angle B. So sine of B is again the opposite over the hypotenuse. So in this case, it's going to be AC over AB. The cosine of angle B is going to be the adjacent over the hypotenuse. So adjacent is going to be BC over AB. And the tangent of angle B is going to be the opposite over adjacent. Okay, so that's going to be AC over BC. Okay, now look at the two columns here and see if you can see any relationships. Okay, anything that looks the same. Okay, so notice that the sine of A, which is BC over AB, is equal to the cosine of B, which is BC over AB. Okay, and the cosine of A, which is AC over AB, equals the sine of B, which is AC over AB. And then how are the tangents related? Well, notice that the ratios of the tangents are reciprocals of each other. Okay, so the sine and the cosine of the two angles are related, and the tangents of the two angles are related. But the whole point here is that in a right triangle, we can use these ratios to find missing values. So for instance, if I have this right triangle, and I know this is 84, this is 38, this is my right angle, and I want to know the length of this side and the length of this side. Well, in terms of this angle, then this is opposite and this is hypotenuse. So which of the trig functions uses opposite and hypotenuse? It's sine. So I can do sine of 38 is equal to x over 84. Then to solve for x, so I get 84 times the sine of 38 equals x. And so what you want to do is pull out your calculator, and you're going to do the sine of 38. So you're going to get x is approximately 84 times 0.6157, which is approximately 51.7188, or approximately 52 if we round to the nearest, I'm sorry, not degree, if we round to the nearest whole number, okay, to the nearest integer. So to find y, well, I look at the angle and I say, well, y is adjacent, so, and I know the hypotenuse, so I would use cosine. So to find y, I would do cosine of 38 degrees is equal to y over 84. And then I would solve for y by multiplying both sides by 84. So I would get 84 times the cosine of 38 equals y. Then on my calculator, I would get the cosine of 38 is 0.7880. And so I would get then that y is approximately 66.1920, or if I round to the nearest whole integer, 66. Okay, so if I have an angle of 38 degrees in a right triangle, and I know the hypotenuse is 84, then I know the leg, this leg has to be 52 units long, and this leg has to be, well, approximately 66 units long. Okay, so we can use that to find the lengths of sides. But it turns out that we can also use it to find the actual angle. Okay, so if I want to find the actual angle, example, so this is my right angle, this is n degrees, this is 20, and this is 12. So in terms of this angle, I need to figure out which trig function I can use. So I have the opposite, and I have the hypotenuse. So opposite and hypotenuse are sine. So I can say then, I can set up the proportion sine of n is equal to 12 over 20. So sine of n degrees, 12 divided by 20 is 0.6. Okay, and so what I want to do is I want to find the angle. So when I want to find the angle, we use what's called the inverse function. So we say n degrees is equal to sine inverse of 0.6. And on your calculator, if you look above the sine button, you'll see a sine inverse. And so if you do sine inverse of 0.6, you get n is equal to 37 degrees. So the measure of that angle must be 37 degrees. Okay.